Hi, folks. Once again, welcome to another episode of YFTT. We are, as always, this is a talk by engineers for engineers. So you get to go into all the details and especially demos. It's a lot of demo-based, explanation of what happens. So I have with me Kavya Shivashankar. She's going to talk about JSONB data types and secondary indexes in YCQL. So maybe just give a quick intro, Kavya, and show us what you have.
Sure. Thanks, Karthik. Hi, I'm Kavya Shivashankar. I'm a senior solutions architect in the customer success team at Yugabyte. I've been at Yugabyte for slightly close to a year and a half now, and it's a great company to be in. Thank you for that, Karthik. And I'm ready to jump in whenever you are.
Yeah, let's start. Yeah. And folks, any questions, please make it interactive. Just drop a comment in the LinkedIn comment or wherever, and we'll get right back to you.
Okay, cool. Okay, so welcome everybody. So today I'm going to be talking about JSONB data type and secondary indexes in YCQL. So as you know, Yugabyte, many of you may already know that YugabyteDB has two different APIs, the SQL API, which is Postgres compatible, and the YCQL API, which is Cassandra compatible. These features in YCQL are specific to that Cassandra compatibility that we offer in YugabyteDB. So here's the agenda that I'll be going through over the next 30 minutes. The first section of the talk today will be around JSONB. How do you use it? The kind of the different kinds of updates that you'll be doing, the different operators that you have that YCQL gives you to enable querying a JSONB column. The next section will go into the secondary indexes supported in YCQL, and also the different types of secondary indexes that YCQL has in its feature list. Then lastly, we'll marry the two concepts, the JSONB and the secondary indexes, and see how you can enable secondary indexes on JSONB data type. Again, we'll be covering the covering indexes and the partial indexes for JSONB, secondary indexes with JSONB data type. I have a lot of live demos, so you may find me switching back and forth between the presentation mode and my terminal mode. During this whole course of 30 minutes.
Awesome.
Okay, so the first section is the JSONB data type in YCQL. So what is JSONB? JSONB is like a semi-structured document type of data, right? And in YCQL, it is a data type that you can define a column with. The B stands here for the binary format. That is, so though you give the entire document structure to be stored in the database, and behind the scenes, it's actually stored in binary format. So it's really a compressed form of storage for that JSON document. The different attributes provided in the JSON document are stored in a sorted order. So having it sorted allows you an efficient search of the attribute information itself. The JSONB, or rather the JSON structure can have arrays, and these arrays are stored in such a way that random access to any of the indexes in that array is possible, right? So the advantage of having binary and sorted is that you can search. It allows for easy search and faster retrieval of attributes that are inside that JSON document. So I have an example.
I think an anecdote is that JSONB is actually the way Postgres does it as well, right? And so we try to keep it similar across the two, if I'm not mistaken, right?
Yeah, that's correct. Yeah.
Got it. All right, keep going. Yeah.
So here's an example of how I have a table. It's books, and it has a book ID, and the details of the books are all in the details column that is defined as a JSONB structure. We'll talk about it in the examples, but keep this structure in mind. Once we go to the terminal, we'll see how it is defined and execute a few queries around each of those attributes. Now, in order to facilitate access to these JSON attributes, YCQL supports the JSONB operators, which is a single arrow operator and a double arrow operator. The primary difference between a single arrow and a double arrow operator is in the type of the return object that this operator gives when you use it in a select query, right? A single operator returns a result of type JSONB. So it is another JSON structure that's returned back to the user who's querying the the JSONB attribute or the entire JSON column. And the double arrow operator gives you a text or a string representation of that JSON, whether it's a nested JSON or even the value associated with an attribute. That's the type that it gives you is the text or the string type. So how do you use these operators to query a JSONB column? So on the left side of my screen, I have a sample query with a sample output. We'll go through I'll quickly take a couple of minutes to explain what the structure looks like, and I'll walk you through how you can query those different attributes with a live demo. So the books, the details column of the books is actually a JSONB column. So within that JSONB column, I have for ID is equal to 5, I have author, which is again a nested JSON. Author attribute, the editor's attribute is an array attribute, which has 3 elements in the array, Melissa, Mark, and Jason and John. The genre is a simple attribute, genre, name, and year are simple attributes. So let's take a look via the terminal as to how we can query it. So I'm going to...
You can make your font size a little bigger. If not, it's okay.
Is that better?
Yeah, that's great. Yeah, that's
okay.
good.
Okay, so let me describe books, and we'll see that this is the same structure that I talked about. And I'm going to say select details where ID is equal to 5. So this is the same JSON structure. Now let's see how I can pull up the author information. The query that I'm going to use is this. It's a single arrow operator, essentially saying that give me the author attribute that is stored in the column details for the ID is equal to 5, right? It returns me the nested JSON structure. So it's nested JSON structure, the value of it. But this value itself is of type JSON, right? But what is the difference? So now if I use double arrow for the same author, I get the same result, but the difference being is in the type of this response that is returned. So this, if you have a calling application, you'll need to deserialize it with a JSON adapter, but this is a plain text or a string where you can parse it or whatever appropriate transformation that's required on it. So the next example that I have is editors is an array within this JSON structure. How do I get all the editors in that particular column? I can use a single operator, but if I want to choose, let's say the second element, I can give that subscript. The subscript starts from 0. So second element means it's 1. And here I get that the second editor, who is Mark, in this particular JSON document. Now, similarly, within this nested structure, if I want only the first name, I can use that double operator, that kind of that redirection from details. I go to author, which is an attribute, and from author, I use the double operator to get me the first name. So this is how you use operators.
Got it. Makes sense.
Kind of, it can go to any level of redirection depending on the nesting levels that are there within that JSON document. Okay, so here we'll talk about how do you insert or update JSONB columns. So insert is as straightforward as any other data type. You include the entire JSON document within that insert statement, and boom, it's inserted into the database. Now, to update a row or to update a row that has a JSON document, there are 2 different ways to do that. One is you can do a complete replace. So you'll say update and update that particular column for that particular ID and include the entire JSON there. That is an option. The other option we have is also to provide that particular attribute using the right operator with the right value and say update it for a particular ID. So let's take a look at how that works. So in my first example, I'm going to insert this fully. This is of ID is equal to 6. I don't have this inserted. So my insert went through fine. Let's actually try and query it to make sure that to make sure that inserted. So I see that this is the record I inserted. It's yeah. And I'm going to update publishing house for this. So the first approach that I'm going to use is to update the entire JSON. So again, I select on that.
What did you update in this thing? Publishing house, you've added in a new attribute. Got it.
Yes. It's gonna, give me one moment. Let me resize this a little bit so that.
Yep.
So I've added publishing house, but the publishing house has ampersand rather than the complete and, right? So we'll look at how we can update it without having to use the entire JSON structure now. I can just use that attribute. So I have update books, set details, publishing house. So I've called only the attribute using this single arrow JSON operator. And then I've corrected the ampersand and to A and D English and for this particular ID. And then if I look at it here, you see that it's got updated from and to and. So I can use an update statement to update a specific attribute only, and I don't necessarily have to give the entire JSON all the time.
And if I'm not wrong, Kavya, there's actually an operator. I don't know if it's a plus equal. So there's some operator where you can add a new attribute without specifying the whole JSON. Is that right?
It's the same attribute, same operator, Karthik. So that's my next example.
Okay, got it. Okay.
Yeah. So here in this example, update book set details, I add a new attribute. So let's take a look at that here. So I have this. So I don't have language. If you take a look at this, I don't have language here. But now I'm going to add language into this JSON. And I use details, single arrow operator, and specify the attribute. This is important because this is what directs YCQL to understand that, hey, I'm adding an attribute, right? And it understands whether it's a new attribute or an existing attribute. And now if you look at it, language English got added here.
You don't need to specify the whole thing. You can just be very efficient with, it's just like an upsert, right? You just add it on the fly. Got it. Makes total sense. This is awesome.
Correct. Yeah. Yeah. So yeah, these two operators, you can, with these two operators, you can pretty much do any kind of CRUD operations on a JSONB column in the in YCQL. Okay, so now that we have covered a very important feature that's there in YCQL, which is JSONB, let's move over to secondary index and I'll talk about what secondary indexes are and in YCQL, what it means to us. So what is a secondary index? So in Cassandra and in YCQL, most of the tables are driven by having a primary key, right? You access data based on what your primary key for that particular table is. So secondary index is an index on anything other than the primary key column, right? It can be created on one or more columns. And how does this help? It enables you to look up by another column other than the primary key. And also having an index will expedite that process or expedite the process of access and make it faster. So why do we need a secondary index and what is the advantage of that in YCQL? If you know, if you have some idea about the way Cassandra data modeling works, you need to have access patterns, and then most of the modeling is done based on the access patterns that is known at that point in time. So you might have a use case that you've implemented in production 6 months down the line. There is one particular query that seemed to be coming from as a new requirement, but you don't really want to change the whole data model. So the advantage with YCQL is that because it gives you a global secondary index, you would, it's easy enough to implement this new query rather than to change that whole set of data model that was already in place.
And you can add and remove indexes on the fly. Is that right? In the background without sacrificing anything on your application side. Is that right?
Correct. You can add and insert index. So if you have to create a new index, there's a backfill operation that happens in YCQL. And it makes it online and transactional. There's no downtime associated with adding an index to a particular table. Yes. So that's the huge advantage of having a secondary index in YCQL. When you compare it with the feature set in Apache Cassandra. So what is secondary index in YCQL? It's global and distributed. That is, it's very similar to a YCQL table. It is sharded and it is distributed across the entire cluster. And the implicit thing that happens, it's automatically updated when the primary table is updated. So in YCQL, when a write comes into the main table, until that all the associated indexes are updated, until they are not, I mean, it waits to acknowledge that write until all the indexes are updated. So it is consistent with the secondary index update is consistent with the primary table update, which makes it a very important feature to have, right? Because you have both your primary table and your secondary indexes in sync all the time and consistent. Now, how does it do it, and how does YCQL do it? It uses behind the scenes, it uses distributed ACID transactions to manage that, to manage the consistency between the primary table and the different secondary indexes that may be there. And YCQL does not have any restriction on any number of secondary indexes that can be on them, right? You can have 1, 2, many. But the trade-off that you have to know is that because there's an implicit management to manage the consistency between the consistency is automatically managed. The trade-off is that there is the write latency is slightly higher because now you have to, along with the primary table, you have to update all of the secondary indexes. Consistency is not a problem, is a problem that is already solved by YCQL. Right? In terms of
makes sense. It makes total sense. Yeah. So
those additional writes is what you have to be aware of, and obviously because now there are more objects, there is more storage space associated with it. So in terms of disk provisioning and all that, you'll have to make sure you have enough space accounted for it, provisioned for it. The other interesting thing about the secondary index is that along with the column specified on the secondary index, it also gets all of the primary key columns from the main table. So it's a composite just looking at the secondary index, it's a composite set of keys which has the secondary index key along with all the different columns of the primary key. Now, because secondary index relies on distributed transactions behind the scenes in YCQL to maintain that consistency and maintain maintain the data synchronicity between the primary table and the secondary index, it has to be any table that needs secondary index has to be enabled with transactions is equal to enabled true. By default, if you don't specify this in YCQL, the transaction property is enabled to be
and just to be clear, this is multi-row or multi-shard transactions, right? This is by default, it's all single row transactional. But when we say transactions is false or true, we are enabling the multi-row, multi-table, multi-index, whatever across things transactions, right?
Right. Yeah.
Right. Okay.
Yeah. So any attempt to create a secondary index without this will error out. So you have to have this enabled. So let's take this example and see. In this particular table, it's a user table. I have ID, first name, last name, email, and city. So which means that I can easily query it by ID. Let's say I have a new request to query from email, right? In YCQL, there is an explain statement which you can use to understand the query plan that uses, right? So if you do that, if you do an explain on email is on the email column, you'll find that's actually using sequential scan. Let's try that. I have a table created already and have some data inserted. So let's try that here. So here's my query where email is where I'm querying by email. There's no secondary index defined yet. Let's validate. Let's make sure that's the case. Users. So it's just a table with a primary key I don't have, and the query plan also confirmed that it's using a sequential scan on the table and it's filtering it by the email. Let's create the secondary index on this. So I'm saying I'll use the create index statement, specify the index name on the table and the column on which I want that index. It's got created. I'll describe the table again. And here you see that this index is associated with the users table, and the column is this, but it also inherited the primary key from the main table. and has this transaction enabled is equal to true. Now, when I do an explain plan on the query that I had by email, where I was querying by email, it tells me that it is using an index scan. So this is where it would, be super fast in terms of it doesn't really have to scan through like a zillion records and to fetch this particular value, right? The index scan is going to make that much faster. So YCQL supports different types of secondary indexes. There is covering index, there's partial index. There's also what is known as unique index. We'll talk about that a little bit, but before that, let's do covering index and partial indexes. Covering index is where you, let's say you have 2 of the 5 columns to be queried. You can include those 2 columns in the index. So the advantage of this is that all of the columns are fetched from that index rather than have to go from the index to the table to get those additional queries. So in our previous example, here, when I query the first name and the last name by email, apart from looking at the index, there is a call from the index to the table that says, hey, get me the first name and the last name, which is now in the main table. Now with covering index, if you include the first name and last name, that additional hop is not required. And so it shows up as index only scan. That means it's getting all of the data from the same index. Let's try that quickly here. So I'll now create a covering index. Got created, and let me try to do this the same explain and see how it converted from an index scan to an index only scan, and it's using this email covering index. And now if I were to describe the table, you will see that there's another index, there's this covering index that's got associated with the table. Right, so here you have this covering indexes gives you this huge advantage of getting higher or a better latency for the same query. Moving on to partial indexes. Partial indexes is to create an index on the subset of data. This is typically used where if you know that you want to restrict the number of the scan to a select few set of records. So typically it is specified by using where clause. This is the syntax, and gives you more optimization because it's now scanning a subset of data rather than scanning the entire set of indexed data. So let's try this out here in our session here. So I'm going to create. So the request, the query that I want to execute is, I want to query by email, and I want all the first name and last name of all people that have last name is equal to D2. So right now it's using the covering index. I will create a partial index and say that this is my partial index where last name is equal to D2, right? I'll create that. Now let's see if it picks up the covering in the partial index. So it did pick up a partial index because
this is almost like relational, right? Like you can keep adding indexes, and so it's semi-relational in that sense. There's no foreign key, but there's a lot of indexes and explain plans and all of that stuff. Yeah.
Right, exactly. And that is a huge advantage for application. You don't have to keep going back and forth between modeling and having to cater to new query access patterns, right? Because the flexibility that comes with these different types of secondary indexes is huge in YCQL.
A few questions. Piet asks if secondary index has all the primary key fields, does it make it very efficient? Or he's stating that he's checking that it does make it very efficient to retrieve if we only need the key fields. So if you're doing a select with only the primary key columns, then even without the include or the covering index, would it be very efficient to go up against the secondary index, which is probably true, right? You don't need to go to do a secondary lookup. Is that correct?
Right. Yeah. If you're accessing by the primary key, if I understood the question right, then you are going to that single table.
No, if you're accessing via the secondary index, but you are only requesting the primary key columns, you're not requesting any extra column, you will only go up against the index table, correct?
Correct. That's correct. Yes. Yes. Because all the columns are available right in that.
You don't need to do a second lookup. So there's your answer, Piet. Frank asks, do we have an intents DB for YCQL tables with transactions? I think the answer is yes. We do IntenseDB-based distributed transactions, as long as Kavya said, you enable that transactions equals true, because it works the same across the two. And Chris asks, I think, a more loaded question, which is, if a table is geo-partitioned, will the index be replicated in each partition, or would there be a single global index, possibly incurring remote lookup across partitions? So yeah, if you want to answer that, go for it.
Go ahead, Karthik.
Either way, so I think, Chris, geo-partitioning is only present in YSQL, not in YCQL, right? So which is because partitioning, as a geo-partition uses table partitions. Table partitions are more of a fully relational concept than what we have here. So in the YSQL API, you can choose to place your indexes in the same region as the table, as the primary table. You do this using another Postgres feature that we've overloaded called, table spaces. So you could create a table space and put it into a region and put both the primary table and all its indexes into the same geo, or you can create the index in a different geo using a different table space. So you get the ability to model this on the fly. But note that this is more of a YSQL feature, not a YCQL feature. Okay, all right, let's keep going. I think this is interesting. So we're shaping the query as the application evolves to do what we want efficiently, which is really awesome. Partial indexes, secondary indexes. Yeah.
So the third type of secondary index that's available in MySQL is unique indexes. Here, as the name suggests, it maintains the uniqueness of that indexed column. So it disallows any duplicate values, and it's a nice way to have automatic data validation built into YCQL for a use case that needs it, right? You just have to create a unique index and then let YCQL take care of not having to add that duplicate value. And anytime you insert and update a duplicate value for a column that is uniquely indexed, you'll get a QL error -300 for this. And we can take a look at that as well. The create unique index, the only difference is that you will have to include the unique key here. And I am going to try and update an existing city. Right, I created the unique index on the city, and here you get this error. So even an insert is going to fail because I'm trying to insert a duplicate value here. The C6. Okay. So those are the secondary indexes, the different types of secondary indexes, right? Now that we saw JSONB and we saw secondary indexes, the next natural question is, can I create a secondary index on a JSONB data type column? And in MySQL, yes, you can create it, and that's a huge advantage. So you can create a regular secondary index on a JSONB attribute, and you can even have covering indexes and partial indexes created with the JSON structure. So let me show you with an example as to how that's possible. So I have this particular users table. I decide to it doesn't have address. So let's add address, because address is a very natural column to have for JSONB, right? You, instead of having line 1, city, AZ, state.
Changing with the country and all that.
Yeah. So I'm going to add address column of JSONB. And here, let me try and describe that again so that you know that it's there. Yes, it's there. And I am going to update 2 records with the address information. And both the addresses are the same, but they're on 2 different records, right? Now, let me try, let's try to, so, you all saw those different operators, right? So let's try to query based on the zip. And let's see what the query plan gives you. So when I try to do address and then zip is equal to 327, because there's no index, it does a sequential scan on all of the values that are there in that particular address column. So rather than have a sequential scan, it's always optimal to use indexes. So I'm going to create index on this particular JSON column like this. And this is the syntax. So you give the table and the entire attribute with the double arrow operator. Now the indexes got created, and I'm going to try the same explain. right? So now, it's pretty evident that it is an index scan here using that index that we just created. So again, this is like that huge compounded effect of having the flexibility of JSON and the indexing capability on JSON. Let's see what happens when you do the select, so there you go. I had updated 2 records and those 2 records are retrieved. Now you can also create a covering index with JSONB. So this, okay, that's my next slide. Here you can, this is the covering index portion. So you can create the covering index and partial indexes with a JSONB column. And let's see it with an example. The covering, so I have the same index, I have a different index, but on the same attribute. But I've now included the first name and the last name. So this index is created. When I query the and do an explain on it, it's now using the covering index here, and it's an index only scan. So see,
this is the automatic, the optimizer doing it automatically, right? You didn't even have to hint. Yeah, makes sense.
Yeah.
This is awesome.
So this is, look at how the feature is getting compound. The benefit of the feature is getting compounded.
Yes, that's right. That's right. And if you chose a column that's not included, then probably it would fall back to the regular secondary index. Yeah.
And then there's that additional hop to the table.
Yeah, and the additional hop. Yeah. So it's a trade-off between data set size and efficiency and the query pattern. Right. So.
Right. So we did the covering index, and then I'll walk you through the partial index here. So here where we've used a where clause where email is equal to Skywalker. Again, the attribute is the same. The JSON attribute we want to index is same. Let me try this here. I'm trying to select star now. So it is an index scan, not index only, because it needs to go to the table, but the index that it selected is this partial index.
Yeah, makes total sense. Yeah, more and more restrictive or flexible according to what you do. Yeah, makes sense.
Yeah. So this is like, so here you have flexibility and you have this efficient access. Combining them together for any use case kind of like gives you that like superpower, especially given that you don't have to change the model that you worked with maybe a year ago, but still have the ability to add this new access patterns into that use case. And yeah, that is pretty much what I had for today, Karthik.
Fantastic. Yeah, this was awesome. Yeah, thank you for walking through this. This was really good. I really enjoyed it. It looks like a lot of people had good questions also. So thank you, Kavya. Really appreciate all the effort. Thank you, everybody, for joining us as always. And we'll have another of these sessions I think in a couple of weeks. But anyway, next week we have an open office hour, same place, same time. If you have questions, I think there is a question actually that Piet asked, which is, if only there's time, that's okay, we'll take it, which is what about range queries where age between 20 and 30, is it ascending, descending, sharded, etc. I think you can specify the type of index, but YCQL supports only hash indexes. YSQL supports hash and range, if I'm not wrong. So that's your answer, Piet. Hopefully that helps you. I think there are more questions here. Maybe we can answer it offline. But Jim asks query performance differences between JSONB and YCQL versus YSQL. The answer is not really. So they both work the same way, more or less underneath. So anyway, folks, feel free to keep asking more questions. I think Kavya will take a look at it on the LinkedIn thread and get back to you folks, or you can join our community Slack, yugabyte.com/Slack. You can see it on the screen here, and just go to the YFTT channel. Thanks everybody for joining us. See you next week. Thank you.
Thank you.
Thanks, Kavya. Thanks, Kavya. Thanks a lot.